Imagine waking up one morning and the ocean has moved, not by a few feet, by miles, inland. The coastline where your people have lived for thousands of years, where your ancestors built settlements and raised families and developed sophisticated ways of life, it's gone, swallowed by waves that just keep coming. Not in one dramatic tsunami, but relentlessly, year after year, decade after decade, until entire landscapes vanish beneath the sea. This actually happened 11,600 years ago. And it erased civilizations we're only now beginning to discover. Today, when we think about ancient history, we picture Egypt, Mesopotamia, the first cities that emerged around 5,000 years ago. That's where civilization supposedly began. Except there's a problem with that story. A massive, ocean-sized problem. The most valuable coastal land where humans would naturally build their most advanced settlements. It's all underwater now, hundreds of feet below the surface, and it's been down there for over 11,000 years. If you're watching this to fall asleep, perfect. That's why I make these. So maybe subscribe and tell me where you are and what time it is. I read the comments, and it's wild. Tokyo at sunrise, London at lunch, Los Angeles at midnight, all experiencing this story simultaneously. Here's what keeps archaeologists up at night. Every ancient culture on Earth has flood myths. Every single one. The story of Noah's Ark. You know that one. But did you know the Mesopotamians had the Epic of Gilgamesh with an almost identical flood story written down 1,000 years before the Bible? The ancient Greeks had Deucalion's flood. Hindu texts describe Manu and a great deluge. Chinese mythology records the Gunyu myth of catastrophic flooding. Indigenous Australians have dreamtime stories of the sea rising and drowning the coastal lands. Native American tribes from the Pacific Northwest to the Amazon tell stories of a world-destroying floods. For centuries, scholars dismissed these as pure mythology, primitive stories, religious allegories, nothing more. But what if they're not myths? What if they're memories? Distorted by thousands of years of oral tradition, wrapped in supernatural explanations because ancient peoples had no other framework to understand what they witnessed, but fundamentally rooted in a real catastrophic event that nearly destroyed human civilization before it really began. The story starts with ice, lots of ice. See, 20,000 years ago, Earth was in the grip of the last glacial maximum. Ice sheets up to 2 miles thick covered most of Canada, northern Europe and parts of Asia. This wasn't like winter. This was geological scale frozen hell that lasted for thousands of years. But here's the thing nobody thinks about. All that ice was water. Water that used to be in the oceans. With so much H2O locked up in continental glaciers, sea levels dropped by about 400 feet. 400 feet, that's a 40-story building worth of ocean just gone, turned into ice sitting on land. When sea levels drop that much, the world transforms. Coastlines extend hundreds of miles beyond where they are today. Land bridges appear between continents. The shallow continental shelves, the most fertile, resource-rich areas of the ocean, they become dry land, perfect for human settlement. And that's exactly where people lived. The most advanced cultures of the Ice Age weren't scattered randomly across the continents. They were concentrated on what we now call the continental shelves, on coastal plains that today lie beneath 200 to 400 feet of seawater. Then, around 14,700 years ago, Earth's climate went insane. The ice started melting fast, way faster than it should have. Sea levels began rising at rates that would terrify modern climate scientists. but the really catastrophic part came at the end of a period geologists call the Younger Dryas. This was Earth's last gasp of Ice Age cold, a 1,300-year climate emergency that started around 12,900 years ago, when temperatures suddenly plunged back toward glacial conditions. Nobody knows exactly what triggered it. Maybe a meteor impact, maybe a massive influx of glacial meltwater disrupting ocean currents, maybe both. What matters is what happened when it ended. 11,600 years ago, the Younger Dryas terminated, not gradually, abruptly. Within a span of decades, maybe even years in some regions, global temperatures shot up. The remaining ice sheets collapsed, and the oceans rose in what scientists call Meltwater Pulse 1b, one of the fastest sea level rise events in geological history. The water didn't rise everywhere equally, but in many regions coastlines retreated inland by dozens of miles within a single human lifetime. Imagine watching the sea advance closer every single year, swallowing your fields, your villages, your sacred sites, everything your culture had built over thousands of years. For the people living through it, this must have seemed like the end of the world, because in a very real sense it was. Their world, the coastal civilizations that had developed during the Ice Age, drowned. Most of the archaeological evidence of who these people were, what they built, what they knew, it's gone, buried under hundreds of feet of sediment and seawater. But it's not completely lost. In recent decades, marine archaeologists have begun finding structures underwater that shouldn't exist. Carefully constructed stone formations, geometric patterns, tool workshops, even what appear to be foundations of buildings, all submerged on the continental shelves at depths that correspond exactly to where coastlines would have been 11,600 years ago. The evidence is down there, waiting. And the story it tells changes everything we thought we knew about the development of human civilization. Because civilization didn't begin 5,000 years ago. It began much earlier. We just haven't been looking in the right place. We've been searching on dry land when the real story's written on the ocean floor. Here's something that'll blow your mind. Everything you think you know about ancient human civilization is based on evidence from the wrong places. We've been looking at highlands, mountain valleys, inland river systems, places that were always above water. But that's not where most people lived 15,000 years ago. The real population centers, the places where human societies thrived and developed their most sophisticated cultures, they're all underwater now. Gone, drowned, buried under hundreds of feet of ocean. Because 20,000 years ago, at the peak of what scientists call the last glacial maximum, the world looked completely different. Sea levels were 120 meters lower than today. That's almost 400 feet. To put that in perspective, that's taller than a 30-story building. That much water was missing from the oceans. Where did it go? It was locked up in ice sheets, massive glaciers that covered most of Canada, northern Europe, and significant chunks of Asia. Ice so thick it was over a mile deep in places, pressing down on the continents with such weight that the land itself was deformed, pushed down into the Earth's mantle like someone pressing their thumb into clay. But here's what that meant for the parts of the world that weren't covered in ice. It meant land, lots of land. Huge expanses of continental shelf that are underwater today were high and dry back then. And these weren't marginal territories. These were some of the most resource-rich environments on the planet. Think about modern coastlines for a minute. They're where the action is. Most of the world's major cities are coastal. Most of the human population lives within 60 miles of a coastline. There's a reason for that. Coasts are where terrestrial resources meet marine resources. You've got fresh water from rivers, game animals from inland, fish and shellfish from the sea, migratory birds following coastlines, plant diversity where different ecosystems meet. It's a buffet. Now imagine coastlines that stretched hundreds of miles beyond where they are today. That's what the world looked like during the Ice Age. And those coastal plains, those vast expanses of land that are now under the ocean, they weren't empty. They were prime real estate, the best places for human societies to develop and thrive. Let's start with Doggerland. If you've never heard of it, don't feel bad. Most people haven't. But 15,000 years ago, Doggerland was the heartland of northern Europe. It was a massive plain, roughly the size of modern Britain, connecting what is now the British Isles to continental Europe. Where there's now the North Sea, cold dark water 200 feet deep, there were rolling hills, river valleys, forests and grasslands. Archaeological evidence dragged up by fishing trawlers tells us Doggerland wasn't just land, it was inhabited land. Fishing nets have brought up stone tools, fragments of worked wood, animal bones with butchering marks. In 2010, a fisherman hauled up a 13,000-year-old fragment of a human skull. Just sitting there on the sea floor along with the remains of mammoths, woolly rhinos and other Ice Age megafauna. But these weren't just random artifacts from scattered nomadic groups. The density of finds suggests substantial populations. Some archaeologists estimate that during the late Ice Age, Doggerland might have supported human populations as large as or larger than the surrounding highlands. Because while northern Britain and Scandinavia were still partially glaciated, harsh and cold, Doggerland was relatively mild. Protected from the worst of the Ice Age climate, fed by major rivers that drained off the European continent, rich with game animals, fish and edible plants. It would have been one of the best places to live in all of northern Europe, and people knew it. For thousands of years, human societies built their lives there, developing local traditions, trade networks, technological innovations. Then the ice started melting. Halfway around the world, an even larger lost land was meeting the same fate. The Sunda Shelf in Southeast Asia makes Doggerland look small. During the last glacial maximum, sea levels dropped so low that the entire shallow sea floor between mainland Asia and the Indonesian islands was exposed. We're talking about an area roughly the size of India. Land that connected what is now Thailand, Malaysia, Indonesia and Borneo into a single massive landmass. Today we call it Sunderland. Back then, it was just the world as people knew it. And what a world it was. The climate was tropical to subtropical. Rivers that now empty into the South China Sea, the Java Sea, the Gulf of Thailand. They all flowed across this exposed shelf, creating vast river systems that fed enormous freshwater lakes and wetlands. The archaeological evidence, what little we can recover from underwater sites and the islands that were once highlands in this lost landscape, suggests this region supported substantial human populations for tens of thousands of years. Stone tools from Sunderland show sophisticated manufacturing techniques. There's evidence of systematic forest management, possibly early forms of agriculture. Some researchers think Sunderland might have been one of the cradles of rice cultivation, that the transition from gathering wild rice to cultivating it happened on river plains that are now under 150 feet of water. If that's true, then one of humanity's most important technological revolutions happened in a place we can barely study because it's been underwater for 8,000 years. And the people who lived there, they weren't primitive nomads barely scraping by. Genetic studies of modern Southeast Asian, Populations suggest their ancestors had been living in the region continuously for over 50,000 years. That's 50,000 years of accumulated local knowledge, technological development, cultural evolution. That's longer than the entire history of agriculture in the Middle East. Longer than the Egyptian civilization by a factor of 10. What did they build in those 50,000 years? What did they learn? What traditions did they develop? We don't know. Most of the evidence is underwater, buried under centuries of marine sediment, or destroyed by the violence of the flooding that drowned their world. Then there's Beringia, the land bridge between Asia and North America. Most people know about Beringia because it's how humans first reached the Americas. Around 15,000 to 20,000 years ago, when sea levels were at their lowest, a 1,000-mile-wide plain connected Siberia to Alaska. Early humans walked across and began colonizing the Western Hemisphere. But here's what the textbooks usually get wrong. Beringia wasn't just a corridor, some narrow bridge that people hurried across to get somewhere else. It was its own world. A massive tundra grassland, what scientists call the Mammoth Steppe, that supported huge populations of megafauna. Mammoths, horses, bison, caribou, all grazing across an Ice Age Serengeti that stretched from Europe to Canada. And humans lived there, not just passing through, but actually living there for thousands of years. Recent archaeological evidence from sites that were at the eastern and western edges of Beringia, the parts that are still above water in Siberia and Alaska, suggests that Beringian populations were substantial and semi-sedentary. They weren't constantly migrating. They were establishing seasonal camps, returning to the same locations year after year, developing regional cultural traditions. Some geneticists think there was a Beringian population that remained isolated on the land bridge for several thousand years, separate from Asian populations to the west and American populations to the east. These people would have developed their own unique genetic signatures, their own cultures, their own adaptations to the specific environment of this lost land. Then, when the seas rose, they disappeared. Either they migrated east into America or west into Asia, or they drowned with their homeland. The central part of Beringia, the heartland where populations might have been most dense, is now under the Bering Strait and the Chukchi Sea. We'll probably never know the full story of what happened there. But it's not just these famous lost lands. All around the world, continental shelves that are now underwater were exposed during the Ice Age. The Persian Gulf was completely dry. The entire Gulf, which is now 300 miles long and averages 150 feet deep, was a river valley. The Tigris and Euphrates rivers, which now empty into the Gulf separately, joined together and flowed as a single massive river system down the center of this valley, before emptying into the Indian Ocean hundreds of miles south of where they flow today. The archaeological implications are staggering. We know that the world's first cities, places like Uruk and Ur, developed along the Tigris and Euphrates around 6,000 years ago. But those cities are near the current coastline. What if there were earlier settlements, precursor communities, down in the valley that's now underwater? What if the real origin of Mesopotamian civilization is buried under the Persian Gulf? Some researchers think exactly that. There are acoustic surveys of the Gulf floor that show possible structural anomalies, things that could be ancient settlements. But excavating underwater sites in 150 feet of water with poor visibility and strong currents, it's incredibly difficult and expensive. Most of these sites will probably never be properly investigated. The same story repeats everywhere you look. The Grand Banks off Newfoundland, now one of the world's richest fishing grounds, was a large island during the Ice Age. The entire Adriatic Sea between Italy and Croatia was a broad coastal plain. The waters between India and Sri Lanka were dry land. Hudson Bay in Canada didn't exist. It was a depression in the middle of the massive Laurentide ice sheet. All of these places, these lost lands, they shared certain characteristics that made them incredibly attractive to human populations. First, they were flat or gently rolling, easy to traverse, easy to hunt across. Second, they were coastal, meaning access to both terrestrial and marine resources. Third, they were fed by major river systems that provided fresh water and attracted game animals. Fourth, many of them had relatively mild climates compared to the glaciated highlands surrounding them. Put all that together, and you get environments that could support human population densities far higher than the harsh Ice Age highlands. Some researchers estimate that during the last glacial maximum, 50% or more of the human population was living on land that is now underwater. If that's true, then most of our understanding of Ice Age human society is based on evidence from marginal populations living in less favourable environments. We're studying the people who lived in the mountains and river valleys because that's what's still above water. But the cultural centres, the places where populations were dense enough to support sophisticated social organisation and technological development, those are all drowned. And here's the really frustrating part. These coastal populations were probably the most advanced societies of their time. There's a principle in archaeology. Population density drives innovation. When you have more people living in closer proximity, you get more social interaction, more exchange of ideas, more specialization of labor. Small scattered groups might be great survivors, but they're not going to be centers of technological or cultural revolution. Dense populations are where things happen. Modern hunter-gatherer societies that lived on coasts, places like the Pacific Northwest tribes before European contact, developed incredibly sophisticated cultures, permanent villages, complex social hierarchies, elaborate art and ceremonial traditions. And they did it all without agriculture, just by exploiting the abundant coastal resources. There's no reason Ice Age coastal populations wouldn't have developed similar complexity, but they left almost nothing we can study. Organic materials, the wood, fibre, bone, and shell that would have made up most of their material culture, it decays rapidly underwater. Stone tools survive, but they're scattered and buried under sediment. Structural remains, if they existed, were probably destroyed by the violence of the flooding or by 10,000 years of coastal erosion and tidal action. What we're left with is fragments, tantalizing hints of something much larger that's been lost. Every few years, fishermen drag up another artifact from the North Sea. Underwater surveys find anomalies that might be structures. Divers exploring submerged caves discover rock art that was made when those caves were above water. But these are just pieces. We're trying to reconstruct entire civilizations from the equivalent of a few scattered puzzle pieces when we don't even know what the picture is supposed to look like. And here's something that should really bother you. We know that sea levels rose. We know approximately when and how fast. What we don't know is what happened to the people who were living on those coasts when the floods came. Did they have time to migrate inland? Did they adapt to the rising seas, moving their settlements back year by year, generation by generation? Or were there catastrophic flood events, sudden inundations that drowned entire regions in a matter of days or weeks? The geological evidence suggests it wasn't a smooth, gradual process. Sea level rise during the deglaciation was punctuated by rapid pulses, periods when massive ice dams would fail, releasing enormous volumes of glacial meltwater into the oceans in geologically brief periods. We can see these pulses in the sea level record, sudden jumps of several meters happening over just a few decades. For people living on those coasts, these pulses would have been catastrophic. Imagine you're part of a coastal community. Your people have lived in this river valley for hundreds of generations. You know every hunting ground, every fishing spot, every source of fresh water and edible plants. Your entire cultural and economic system is built around this landscape. Then, within your lifetime, the sea advances, not slowly, not gently, but in a series of devastating floods. The river mouth, where your people have been harvesting shellfish for centuries, it's underwater. The coastal plain where you hunt game animals, it's becoming tidal marsh. Your settlements, the permanent or semi-permanent camps where your community gathers, they're being swamped by storm surges. What do? You move inland, obviously. But moving isn't simple. The highlands are already inhabited by other groups. They've been living there for generations too. They have their own territories, their own resource claims. Now suddenly you're refugees, climate refugees, displaced by environmental changes you don't understand and can't control. You're competing for resources in territories that are already fully utilized by their existing populations. The result would have been conflict. Population displacement on this scale always generates conflict. Some groups would negotiate, forming alliances or merging with highland populations. Others would fight. The archaeological record from the early Holocene, the period right after the Ice Age, shows increased evidence of violence. Skeletal remains with projectile wounds, fortified settlements, massacres. This is what you'd expect if massive coastal populations were being forced inland by rising seas. But the cultural impact might have been even more significant than the demographic impact. When populations are displaced, they carry their knowledge with them, but they also lose connection to the landscapes where that knowledge was developed. A coastal people forced inland, they bring their fishing techniques, their boat-building skills, their understanding of tides and marine resources. But they can't use most of that knowledge in their new environment. Over generations, that cultural knowledge would fade. Within a few hundred years, the descendants of sophisticated coastal societies might have reverted to less complex lifestyles simply because their traditional knowledge base was no longer relevant. The flooding didn't just drown the lands, it drowned the cultures that had developed there. And maybe that's why we keep finding these anomalies. Societies that seem to appear suddenly in the archaeological record with technologies and cultural practices that don't have obvious local precursors. Maybe they're not spontaneous innovations. Maybe they're the remnants of coastal traditions, carried inland by refugees, preserved in fragmentary form by the survivors of the drowning. The world before the floods was a different planet, a planet with more land, different coastlines, different climate patterns, a planet where some of the most favorable environments for human habitation, the coastal plains and river valleys that are now underwater, supported populations we can barely imagine because we can barely study them. Those populations, they're the missing piece of our prehistory, the lost chapter in the human story. And in a few thousand years, when the ice sheets finished melting and the seas reached their current levels, they were gone, drowned, displaced or dispersed. Their settlements buried under hundreds of feet of water and thousands of years of sediment. Their stories lost except for fragments preserved in the flood myths that cultures around the world would tell for millennia afterward. But before they disappeared completely, before the last of the great coastal plains was submerged, one more catastrophe was waiting. The climate was about to do something that should have been impossible, something that would make all the previous flooding look like a preview. The real disaster, the one that would be remembered in human cultural memory for thousands of years, was about to begin. Picture Earth, 12,900 years ago. After thousands of years of steady warming, the planet is coming alive again. Ice sheets that had covered half of North America and Europe for 100,000 years are finally retreating. Sea levels are rising as meltwater pours into the oceans. Forests are spreading north, following the glaciers as they melt. Animals are migrating into territories that had been locked under ice for millennia. And your ancestors, the descendants of Ice Age survivors, are thriving. Human populations are exploding. Coastal settlements are growing more sophisticated. Trade networks are expanding. The archaeological record from this period shows increasing cultural complexity, larger settlements, more elaborate tools, the first hints of what might become agriculture. The world is getting better. The long nightmare of the Ice Age is ending. Then, without warning, everything stops, and then it reverses. Within a span of perhaps 10 years, maybe less, temperature across the northern hemisphere plummet. Not gradually, not over centuries, but catastrophically fast. Ice sheets that had been retreating for thousands of years suddenly surge forward again. Glaciers that had been melting begin growing. Rivers freeze. Lakes that had thawed turn to ice. The warming trend that had defined an entire era just stops. Welcome to the younger Dryas, Earth's most recent climate emergency and one of the most mysterious events in our planet's geological history. Now, here's what makes the younger Dryas so terrifying. It wasn't supposed to happen. The Ice Age was ending. All the factors that had locked Earth in a frozen state for over 100,000 years were reversing. The planet's orbital cycles were shifting toward warmer patterns. Ice albedo feedback was working in reverse as darker ground absorbed more solar heat. By every measure, Earth should have continued warming steadily for thousands of years. Instead, it plunged back into near Ice Age conditions in less than a decade. To put that in perspective, imagine if Earth's current warming trend suddenly reversed tomorrow, and within 10 years we were experiencing temperatures comparable to the Little Ice Age of the 1600s. That's the scale and speed of what happened 12,900 years ago. The evidence comes from ice cores drilled from Greenland's ice sheet. These cores contained frozen records of Earth's atmosphere going back hundreds of thousands of years. Each layer of ice traps tiny bubbles of ancient air, along with dust, pollen, and chemical signatures that reveal what the climate was like when that snow fell. And the Greenland ice cores show something that shouldn't be possible. Temperature proxies indicate that average temperatures in the North Atlantic region dropped by about 15 degrees Celsius in less than a decade. That's not a gradual cooling trend. That's a climate system breaking. The same rapid cooling shows up in ice cores from across the Northern Hemisphere. Europe, Asia, North America, all experiencing the same abrupt shift at exactly the same time. But here's where it gets really interesting. We still don't know exactly what caused it. There are two main competing theories, and both are terrifying in different ways. The first theory involves an extraterrestrial impact. The hypothesis goes like this. Around 12,900 years ago, Earth encountered a debris field from a fragmenting comet. Multiple impacts occurred across North America and possibly Europe, with air bursts and surface impacts releasing energy equivalent to millions of nuclear weapons. These impacts would have ejected massive amounts of dust and debris into the atmosphere, blocking sunlight and triggering rapid cooling. They might also have caused widespread wildfires, with smoke further reducing solar radiation reaching Earth's surface. The evidence for this impact hypothesis is controversial but intriguing. researchers have found a distinct layer in sediments dated to 12,900 years ago containing unusual materials. Microspherules, tiny glass beads that form when rock is melted at extremely high temperatures. Nanodiamonds, which can form during high-energy impact events. High concentrations of platinum group elements, which are more common in asteroids and comets than in Earth's crust, and a layer of carbon-rich material suggesting widespread burning. Critics argue these materials could form through natural processes without requiring an impact. Forest fires can create similar residues. Volcanic activity can concentrate platinum group elements. The debate continues, with new studies supporting or challenging the impact hypothesis every few years. But there's a second theory, one that doesn't require cosmic intervention at all, and in some ways it's even more disturbing because it suggests Earth's climate system is capable of flipping into catastrophic cooling mode all by itself. This theory centers on something called the Atlantic Meridional Overturning Circulation. It's basically a massive conveyor belt of ocean currents that moves warm water from the tropics to the North Atlantic and returns cold water southward at depth. This circulation system is crucial for maintaining moderate temperatures across Europe and North America. Without it, these regions would be far colder, despite being at relatively low latitudes. This system works like this. Warm, salty water flows north at the surface. As it reaches the cold waters of the North Atlantic, it cools down and becomes denser. Cold, salty water is heavier than warm, fresh water, so it sinks to the ocean floor. This sinking creates suction that pulls more warm water northward, maintaining the circulation. It's a self-sustaining cycle that has been running for millions of years. But there's a problem. The system is vulnerable to disruption by fresh water. If you dump massive amounts of fresh water into the North Atlantic, it dilutes the salty ocean water, making it less dense. If the surface water can't sink anymore, the entire circulation system can shut down. And when the conveyor belt stops, the northern hemisphere freezes. Now remember what was happening 12,900 years ago. The Ice Age was ending. Massive ice sheets were melting. Meltwater was pouring into the ocean. But most of this water was flowing into the Pacific, or south through the Mississippi River, or through other routes that didn't interfere with the Atlantic circulation. The system remained stable as long as meltwater entered the ocean gradually and didn't concentrate in the North Atlantic. But North America's ice sheets weren't just any glaciers. They were the largest accumulation of ice outside Antarctica, in some places over 2 miles thick. As they melted, massive lakes formed at their margins, trapped behind ice dams and ridges of glacial debris. These weren't normal lakes. These were inland seas holding more water than all of today's Great Lakes combined. The largest was Lake Agassiz, named after the scientist who first proposed ice ages existed. At its maximum extent, Lake Agassiz covered an area larger than any current freshwater lake on Earth. It stretched from Saskatchewan to Ontario, from North Dakota to Minnesota. In some places it was over 200 meters deep, and it was held back from the ocean by nothing but ice dams and glacial debris. As the climate warmed, these ice dams weakened. For thousands of years they held, occasionally releasing floods but remaining fundamentally intact. The meltwater found outlets to the south, flowing through the Mississippi River system to the Gulf of Mexico. Then, around 12,900 years ago, something changed. Either an impact event weakened the ice dams, or they simply reached a critical threshold where they couldn't hold anymore. Suddenly, catastrophically, the eastern outlets of Lake Agassiz opened. Trillions of gallons of fresh water didn't flow into the Gulf of Mexico. They poured into the North Atlantic through the St. Lawrence River system. The volume was staggering. Estimates suggest the discharge was equal to roughly 50 Amazon rivers, flowing simultaneously for several years. This wasn't a flood. This was a planetary-scale drainage event. All that fresh water spread across the North Atlantic, floating on top of the denser salt water, creating a cap that prevented normal ocean circulation. Without the sinking of cold water to drive the system, the Atlantic conveyor belt shut down. Warm water stopped flowing north. The climate of the northern hemisphere, dependent on that heat transport, collapsed into near ice age conditions within a decade. That's the meltwater pulse theory, and unlike the impact hypothesis, we know for certain that these meltwater events happened. The geological evidence is unambiguous. Massive floods did occur. Lake Agassiz did drain catastrophically multiple times. The routing of meltwater did change around 12,900 years ago. The only question is whether this was the primary cause of the younger Dryas cooling, or whether an impact event triggered the drainage. Honestly, both theories could be partially correct. Maybe an impact event caused the initial cooling and also destabilized ice dams that were already weakening. Maybe the catastrophic drainage of Lake Agassiz then sustained and amplified the cooling that impacts had initiated. The two mechanisms aren't mutually exclusive. But here's what we know for certain. Once the younger Dryas began, it didn't just cool things down. It created wildly unstable climate conditions that lasted for 1,300 years. The temperature record from ice cores shows rapid fluctuations within the overall cold period. Temperatures would drop, then briefly warm, then drop again. Precipitation patterns changed dramatically, with some regions experiencing severe droughts, while others saw increased rainfall or snowfall. The ice sheets responded to these changes, but not uniformly. In some regions, glaciers surged forward, advancing kilometers per year and crushing everything in their paths. In other areas, complex interactions between ice dynamics and meltwater created unstable conditions where glaciers would surge and retreat repeatedly. Most importantly for our story, the younger Dryas created a planetary landscape loaded with potential energy. Massive ice sheets were poised in unstable configurations. Giant glacial lakes held back by weakening ice dams contained enough water to raise global sea levels by meters. Permafrost locked in place by cold conditions was maintaining the stability of vast regions. Everything was balanced on a knife edge, and human populations, which had been expanding and developing more complex societies during the warming period, suddenly found themselves facing a climate catastrophe. The archaeological record from this period shows dramatic cultural changes. Some settlements were abandoned, others show signs of stress, reduced population, simpler toolkits, trade networks that had been expanding contract suddenly. But here's the thing, humans didn't go extinct, they adapted, they survived. Just like their ancestors had survived the original ice age, they found ways to cope with the renewed cold. They moved, they changed their subsistence strategies, they developed new technologies. They persevered. For 1,300 years, they endured conditions that shifted unpredictably from bad to worse and occasionally back to merely difficult. Communities that had been developing agriculture went back to hunting and gathering. Coastal settlements moved to follow changing shorelines. Northern populations migrated south. Southern populations adapted to colder, drier conditions. And then, around 11,600 years ago, everything changed again. The younger Dryas ended, but it didn't end gradually. Like its beginning, the termination was catastrophically abrupt. Temperature records show warming of about 10 degrees Celsius in less than a decade. In some regions, the shift might have happened even faster, perhaps in just 3 to 5 years. The ice sheets that had surged during the Younger Dryas began melting at unprecedented rates, not the slow, steady melting of a normal deglaciation, catastrophic melting. Glaciers that had advanced during the cold period were suddenly stranded in warmer latitudes, melting from below, from above, from their sides all at once. Ice sheets began collapsing in sections, with vast areas simply disintegrating within years. All that ice dams that had been strengthened by 1,300 years of cold, holding back even larger glacial lakes than before, now faced temperatures that would have been warm even without the Younger Dryas. The lakes which had grown during the cold period as glacial meltwater accumulated were at maximum capacity. The dams, rapidly weakening in the sudden warmth, were about to fail. And when they failed, they didn't fail gradually. Ice dams don't slowly erode when they break. They catastrophically collapse, releasing their entire volume in a matter of days or weeks. Lake Agassiz alone, which had refilled during the Younger Dryas, contained enough water to raise global sea level by about 0.5 meter. Other glacial lakes across North America, Europe, and Asia held additional massive volumes. When these dams failed within a span of perhaps 50 to 100 years, they released floods that make modern river floods look like puddles. We're talking about discharge rates that exceeded the combined flow of all rivers on Earth today. Walls of water hundreds of feet high rushing across landscapes at speeds that allowed no escape. Coastlines that had been stable for over 1,000 years suddenly inundated within years. But we're getting ahead of ourselves. We'll get to those floods in detail in the next section. For now, understand what the Younger Dryas did. It wasn't just a cold period, it was a climate system stress test that loaded the planetary landscape with catastrophic potential. It created unstable ice configurations that would collapse spectacularly when warming returned. It filled massive lakes behind weakening dams. It built up permafrost and ground ice that would destabilize when temperatures rose. It set the stage for the greatest rapid sea level rise event of the past 20,000 years. And it did all this while human populations were living along coastlines that were about to be erased from existence. The Younger Dryas created the conditions. The warming that followed triggered the catastrophe. And coastal civilizations that had survived the cold period had no idea what was about to hit them. Because here's the thing about those coastal peoples. They had adapted to 1,300 years of cold, relatively stable conditions. Yes, the climate fluctuated, but sea levels during the Younger Dryas were relatively constant. The shorelines they lived on had been the shoreline for dozens of generations. As far as they knew, as far as their grandparents could remember, as far as their oral traditions could reach, the ocean had always been right there. They built permanent settlements. They developed maritime technologies. They created trade networks linking coastal communities across thousands of kilometers. They accumulated knowledge about tides, seasons, fish migrations, shellfish beds. They raised children who had never known any world except the coastal one. And they had no concept that the world could change as fast as it was about to change. No understanding of ice sheets or glacial lakes or climate tipping points. No way to predict what was coming. They just knew the weather was getting warmer, which probably seemed like a good thing after 1,300 years of cold. Then the floods came, and when they came, they didn't come gradually. They came as a series of catastrophic pulses that would reshape Earth's coastlines and erase entire civilizations from existence. But that's the next part of our story. First, we need to understand exactly how those floods happened, where the water came from, and how much of it there was. Because what's about to happen makes the younger Dryas look like a warm-up act for the main event. Around 11,600 years ago, something happened that would change the face of the Earth forever. Not instantly, not dramatically enough that anyone alive would see it all at once, but relentlessly, unstoppably, year after year after year. The oceans began to rise, not the slow, steady rise you might imagine, not the kind of gradual change that people could easily adapt to by just moving a little further inland each generation. This was something different, something faster, something that would ultimately swallow millions of square kilometers of land and everything on it. Scientists call it Meltwater Pulse 1b, which is probably the most boring name ever given to one of the most catastrophic events in human history. Because here's what that clinical term actually means. Between approximately 11,600 and 11,300 years ago, sea levels rose somewhere between 15 and 28 meters. That's 50 to 90 feet for those of you thinking in imperial units in just 3 centuries, maybe less. Now you might be thinking, okay, 15 to 28 meters over 300 years, that's only 5 to 9 centimeters per year. That doesn't sound so bad. People could just move, right? But that's not how it worked. Because flooding doesn't happen uniformly. It doesn't politely rise exactly 5 centimeters every January 1st, giving everyone plenty of time to relocate their villages a few meters inland. It comes in surges. It comes with storms. It comes during spring tides and seasonal melt events that can raise water levels meters in a matter of days, then leave that new high water mark as the permanent coastline. Imagine you're living in a coastal village 11,600 years ago. Your people have been living on this land for generations, maybe centuries. You know every fishing spot, every shellfish bed, every freshwater spring. You know where the game trails are, where the migratory birds nest, where the edible plants grow thickest. Then one spring, the ocean doesn't retreat as far as it usually does after the winter storms. The beach you've always known is smaller. Some of the tidal pools you've harvested from since childhood are now permanently underwater. Maybe you think it's just a weird year. Climate fluctuates. Next year will be different, but next year is worse, and the year after that. Within a decade, the sacred cave where your people have painted ceremonies for generations is flooding at high tide. Within 2 decades, the entire lower village where the best fishing families lived has to be abandoned. The spring that provided fresh water is now brackish, contaminated by seawater intrusion. The shellfish beds are too deep to harvest, and the ocean just keeps coming. Within 50 years, everything your grandparents knew is underwater. The landscape of your childhood is gone. And you're not just moving once, you're moving again and again every few years, abandoning settlements and resources and sacred sites, pushing further inland into territories that are already occupied by other groups who aren't exactly thrilled to see refugees showing up and competing for their resources. This went on for 300 years, 10 generations of continuous retreat. 10 generations of watching the world drown. That's what Meltwater Pulse 1b actually meant for the people who lived through it. So what caused this? Why did the ocean suddenly decide to swallow so much land so fast? The answer is actually pretty straightforward, though the scale of what happened is almost incomprehensible. 2 massive ice sheets that had dominated the northern hemisphere for the past 100,000 years suddenly became unstable and began collapsing into the ocean. Not completely, not all at once, but fast enough and massively enough to add tens of trillions of tons of fresh water to the world's oceans in just a few centuries? The first culprit was the Laurentide ice sheet, the massive dome of ice that had covered most of Canada and the northern United States during the last glacial maximum. At its peak, this thing was over 3 kilometers thick in some places. 3 kilometers of solid ice pressing down on the Earth's crust so hard that the land beneath it was actually sinking. But by 11,600 years ago, the Laurentide was dying. The younger Dryas cold snap had temporarily stabilized it, but when that ended and temperatures began rising again, the ice sheet went into catastrophic retreat. The southern margins began melting first, creating enormous proglacial lakes, temporary bodies of water trapped between the retreating ice and the land. Some of these lakes were bigger than all the modern Great Lakes combined, and they were unstable. When ice dams failed, which they did repeatedly, these lakes could drain in a matter of weeks or months, sending unimaginable volumes of water cascading into the ocean. We're talking about floods that would have made the Mississippi look like a creek. Rivers of meltwater kilometers wide, carrying icebergs the size of buildings, draining so much water so fast that they probably lowered the lake levels by dozens of meters. And all that water had to go somewhere. It went into the Atlantic Ocean, raising sea levels, disrupting ocean currents, flooding coastlines from Newfoundland to the Caribbean. But the Laurentide wasn't acting alone. At the same time, on the opposite side of the planet, Antarctica was having its own crisis. The West Antarctic ice sheet, which had been stable through most of the Ice Age, began experiencing what glaciologists call marine ice sheet instability. This is a particularly nasty form of ice sheet collapse that happens when ice that's grounded on bedrock below sea level starts to retreat. Here's the problem. Much of West Antarctica sits on bedrock that's actually below sea level. The ice sheet was stable when it was thick enough and cold enough, but once warming started and the margins began to thin, seawater could intrude underneath the ice. Water is much better at melting ice than air is. Once ocean water gets under an ice sheet, it can melt it from below, creating a positive feedback loop. The ice thins, more water intrudes, more melting happens from below, the ice thins further. Eventually, entire sections of the ice sheet can essentially float off their bedrock foundations and collapse into the ocean. That's what appears to have happened around 11,600 years ago. Large sectors of the West Antarctic ice sheet became ungrounded and began sliding into the Southern Ocean. The evidence for this comes from multiple sources. Sediment cores from the ocean floor around Antarctica show massive deposits of ice-rafted debris, rocks, and gravel that could only have been transported by icebergs, dating to exactly this period. The size and distribution of these deposits suggest not just normal iceberg production, but catastrophic discharge events, essentially large chunks of the Antarctic ice sheet breaking off and floating away. Meanwhile, coral reefs tell the same story from a different angle. Corals are incredibly useful for reconstructing past sea levels because they grow right up to the surface of the ocean. When sea level rises, corals can grow upward to keep pace, but only up to a certain rate. If sea level rises too fast, the coral drowns, buried too deep to photosynthesize. If sea level rises slowly, coral growth keeps pace, creating a continuous record. By drilling cores into ancient reefs and dating different layers, scientists can reconstruct exactly how fast sea level was rising. And the coral record from 11,600 years ago is dramatic. Reefs from the Caribbean, the Pacific, the Indian Ocean all show the same pattern. Healthy coral growth up to around 11,600 years ago, then sudden disruption. In many places the reefs show what's called a give-up reef, where the corals simply couldn't grow fast enough to keep up with rising sea levels. They drowned in place, preserved as a snapshot of catastrophic environmental change. The dating is precise enough that we can actually see the pulse structure of the flooding. It wasn't a smooth, continuous rise. It came in distinct surges, periods of very rapid rise separated by intervals of slower change or even temporary stability. This tells us the ice sheet collapses weren't gradual. They happened in discrete events, probably triggered by specific mechanisms. An ice dam failing here, a section of marine ice sheet floating off there. Each event dumping enormous volumes of water into the ocean in a relatively short time, then a pause while the system temporarily stabilized before the next collapse. The rate of sea level rise during the most intense phases of Meltwater Pulse 1b was genuinely extreme. Current research suggests peak rates may have reached 40 to 50 millimeters per year in some periods. That might not sound like much, 4 to 5 centimeters annually, but remember, we're not talking about open ocean. We're talking about coastlines with very shallow gradients, the kind of low-lying coastal plains where early human settlements would have clustered. On a coastline with a gradient of 1 in 1,000, which is typical for many river deltas and coastal plains, a sea level rise of 50 millimeters translates to 50 meters of coastline lost. Every single year, for decades. For some populations living on extremely flat coastal terrain, this would have meant abandoning their settlements and moving hundreds of meters inland every few years just to stay ahead of the advancing water. But here's where it gets even worse. The flooding wasn't uniform across the globe. Different coastlines experienced very different rates of inundation, depending on local geography, tectonic activity, and something called glacial isostatic adjustment. Glacial isostatic adjustment is a complicated way of saying the Earth's crust moves up and down in response to the weight of ice sheets. When you pile 3 kilometers of ice on top of North America for 100,000 years, the land underneath actually sinks, depressed by the weight. Meanwhile, areas around the margins of the ice sheet where there's no ice actually rise slightly, bulging upward as mantle material flows away from the depressed regions. When the ice melts, the whole process reverses. The formerly ice-covered regions begin rising back up, a process called post-glacial rebound, while the peripheral bulge areas begin sinking back down. This is still happening today. Parts of Canada are rising several millimeters per year, while areas of the eastern United States are sinking. But 11,600 years ago, this process was much more active, and it had profound effects on relative sea level. If you were living in an area that had been under the ice sheet, like the Hudson Bay region, sea level might actually have seemed to fall even as global sea levels rose. The land was rebounding faster than the ocean was rising, at least initially. But if you were living in the peripheral bulge areas, like the mid-Atlantic coast of North America or large parts of Southeast Asia, you got hit twice. Global sea level was rising from ice sheet melt, and your land was simultaneously sinking as the peripheral bulge collapsed. The combined effect could be devastating. Some areas experienced effective sea level rise rates of 5 to 10 meters per century, 20 times faster than current sea level rise. This regional variation means that while some coastal populations might have had time to adapt gradually, others would have experienced truly catastrophic flooding. The archaeological record, what little survives, reflects this variability. In some regions, we see evidence of gradual site abandonment, settlements that were slowly vacated over decades as resources became less accessible. In other regions, we see what looks like sudden abandonment, sites that appear to have been left rapidly, sometimes with tools and food remain still in place. The difference probably comes down to how fast the local coastline was flooding. The sediment record from drowned river valleys tells a similar story. Before Meltwater Pulse 1b, during the younger Dryas, many river systems had adjusted to lower sea levels by cutting deep valleys. Rivers flowed through these valleys out to sea, creating stable floodplains and deltas where humans could settle. When sea level began rising rapidly, these river valleys began to flood from the downstream end. Salt water intruded into what had been freshwater systems. Estuaries moved upstream. River deltas, which are typically rich in resources and attractive for human settlement, were progressively submerged. Core samples from these drowned valleys show dramatic changes in sediment composition and biological communities over very short time periods. Freshwater species suddenly replaced by marine species. River sediments suddenly overlain by marine clays. These transitions happen over depths, representing just a few decades in many cases. Proof that the environmental changes were rapid enough to prevent biological communities from adapting gradually. And if aquatic species couldn't adapt, what chance did human populations have? By the time Meltwater Pulse 1b ended around 11,300 years ago, the world map had been redrawn. The land area that was lost is almost impossible to comprehend. The Gulf of Mexico had expanded significantly, swallowing vast areas of what had been coastal plain. The Persian Gulf, which had been almost entirely dry land during the Ice Age, was now a deep water body. Sunderland, the subcontinent that had connected Southeast Asia to Indonesia, had been reduced to islands. The English Channel had widened dramatically, turning Britain into a more definitive island. The coastlines of every continent had been pushed inland by dozens of kilometres in some places, hundreds in others, but the flooding didn't stop completely after Meltwater Pulse 1b. The ice sheets continued melting, though at slower rates, for thousands of years. There were subsequent pulse events, smaller but still significant. The 8.2 kiloyear event, which happened around 8,200 years ago, saw another rapid pulse of meltwater, this time from the final drainage of glacial Lake Agassiz in North America. When the last ice dam failed, the lake drained catastrophically into Hudson Bay and from there into the North Atlantic. The volume of fresh water was enough to disrupt ocean circulation and cause a brief but intense cooling event, especially in the North Atlantic region. Sea levels rose another 1 to 4 meters relatively quickly, causing renewed flooding of coastal areas that had thought themselves safe. But by this point, human societies had learned hard lessons about living on coasts. Settlements from this period show evidence of more careful site selection. People were building further from the water, on higher ground, in locations that provided quick escape routes inland. The trauma of the earlier flooding events had been passed down through oral traditions, myths, and practical knowledge. Coastal peoples had become climate refugees, and they remembered it. The geological evidence for these events is now overwhelming. Sediment cores from continental shelves worldwide show the characteristic signatures of rapid flooding. Coral reef records provide precise dates and rates. Glacial geology shows the timing of ice sheet collapse. Ocean sediment chemistry reveals the massive influx of fresh water. All the data points to the same conclusion. Between roughly 11,600 and 11,300 years ago, with subsequent lesser events continuing for several more millennia, the Earth experienced catastrophic sea level rise at rates far beyond anything in the historical record. For coastal populations, this was an apocalypse in slow motion. Not a single dramatic event like a volcanic eruption or earthquake, but a relentless, unstoppable transformation that rendered entire landscapes uninhabitable and forced massive population movements. And here's the thing that should really concern us. The ice sheets that collapsed during Meltwater Pulse 1b weren't being melted by anything as extreme as what we're doing to the climate now. The warming that triggered those collapses was natural, driven by orbital cycles and feedback mechanisms. The rate of temperature increase was actually slower than what we're seeing today. Yet it was enough to destabilize continental-scale ice sheets and cause catastrophic flooding. Today, we're warming the planet faster, and both Greenland and Antarctica are showing signs of the same kind of instability that preceded Meltwater Pulse 1b. Marine ice sheet instability in West Antarctica, accelerating ice mass loss in Greenland, exactly the warning signs we should be paying attention to. Because our ancestors survived Meltwater Pulse 1b, but at tremendous cost. They lost their homes, their resources, their sacred places, their ancestral lands. They became refugees in a world that was already filling up with other humans competing for the same resources. And they didn't have modern technology, global communication, or international cooperation to help them adapt. We do. The question is whether we'll use these advantages, or whether we'll force our descendants to tell flood myths about us, stories of the second great drowning, when humanity once again watched the waters rise and lost the world they had known. So here's the uncomfortable question that nobody in mainstream archaeology wanted to ask for decades. If millions of people were living on coastlines that are now underwater, where's the evidence? Because that evidence should exist. We're not talking about a few scattered campsites. We're talking about entire civilizations, hundreds of generations of human occupation along thousands of miles of coastline. When these coasts drowned 11,600 years ago, they didn't just disappear, they sank. Everything those people built, everything they left behind, it's all still there, sitting on the continental shelf under 300 feet of seawater. The problem is, nobody was looking. For most of the 20th century, archaeologists operated under a simple assumption. Civilization started around 6,000 years ago with Mesopotamia and Egypt. Anything before that was just primitive hunter-gatherers who didn't build permanent structures or develop complex societies. So why bother looking underwater for something that supposedly didn't exist? Then in 1984, marine archaeologist Ehud Galili was surveying the seafloor off the coast of Israel when he found something that shouldn't have been there. Stone structures, not natural formations, but clearly human-made walls, buildings, even a stone well, all of it sitting 26 feet underwater, about 1,300 feet from the modern shoreline. This was Atlit Yam, and it changed everything. What Galili had discovered was an entire Neolithic village, perfectly preserved under Mediterranean sediments, houses with stone foundations arranged in recognizable streets, fireplaces still containing ash, stone tools scattered exactly where they'd been dropped. Most remarkably, the village had a stone well that penetrated down through the saltwater-saturated sediments to reach freshwater aquifers below. This wasn't primitive technology. This was sophisticated engineering from people who understood hydrology and geology. Radiocarbon dating of organic materials from the site gave ages between 8,900 and 8,300 years ago. The village had been built on dry land when sea levels were lower. Then, as meltwater from the final Ice Age pulses raised the Mediterranean, the inhabitants abandoned their homes and moved inland. The sea rushed in, buried everything under sediment, and preserved it like a time capsule for 8,000 years. But here's what made Atlit Yam really significant. The dating put its abandonment right around the end of the meltwater pulses, which means the people who built it were living through the coastal flooding events. They experienced the slow drowning of their world firsthand. They had to make the choice to leave behind everything they'd built and move to higher ground. This wasn't theoretical. This was real people losing their homes to rising seas. And Atlit Yam wasn't unique. Once archaeologists started actually looking underwater, they found settlements everywhere. Off the coast of southern Greece, researchers discovered Pavlopetri, an entire Bronze Age town sitting 13 feet underwater. Streets laid out in a grid pattern. Building foundations clearly visible, a central square. Even what appears to be a complex network of water management channels. The site covers about 123,000 square feet and dates to around 5,000 years ago, making it one of the oldest submerged towns ever discovered. But these were relatively recent sites. Settlements built after sea levels had mostly stabilized. The really interesting question was, what about the older coastlines? The ones that drowned during the massive meltwater pulses 14,000 to 11,600 years ago? What happened to the settlements that existed then? That's where the story gets controversial. Because once you start looking at the truly deep underwater sites, the ones sitting on the continental shelf at depths of 200 to 400 feet, you start finding things that don't fit the conventional timeline. Things that suggest human societies were far more advanced far earlier than anyone wanted to admit. Take the structures found off the coast of Gujarat in India. In 2001, marine scientists using sonar to survey pollution levels in the Gulf of Cambay detected geometric patterns on the seafloor at depths of 120 feet. Follow-up investigations revealed what appeared to be massive stone structures, building foundations, even what some researchers interpreted as a grid-like city layout covering several square miles. The Indian government's National Institute of Ocean Technology deployed underwater robots to collect samples. They recovered pottery fragments, pieces of carved wood, and worked stone tools. Radiocarbon dating of some organic materials gave ages of 9,500 years. Other samples tested even older, up to 31,000 years, though those dates remain highly disputed. The site became immediately controversial. If the structures were indeed human-made and the dates were accurate, it would mean complex civilization existed in India thousands of years before the earliest known cities in Mesopotamia. Critics argued the formations might be natural, or that the dating was contaminated. The debate continues, but nobody disputes that there are unusual features on that seafloor that deserve more investigation. The challenge is that underwater archaeology is incredibly difficult and insanely expensive. On land, you can visually survey vast areas, use ground-penetrating radar, excavate sites relatively easily. Underwater, visibility is often measured in feet, not miles. Currents and sediments bury structures. The equipment required, submarines, remote-operated vehicles, specialized diving gear, costs millions. And the deeper you go, the harder and more expensive everything becomes. This means we've barely scratched the surface. The continental shelves exposed during the Ice Age represent about 8 million square miles of formerly dry land. Current estimates suggest we've archaeologically surveyed less than 1% of those submerged areas. We're essentially searching for evidence of lost civilizations while wearing a blindfold and using only one hand. But the technology is improving. Modern sonar mapping can now create extraordinarily detailed images of the seafloor. Side-scan sonar can reveal features as small as a few inches across. Multi-beam bathymetry can map vast areas quickly, showing the topography of the ocean floor in stunning resolution. Underwater robots equipped with high-definition cameras can explore sites too deep for human divers. And when researchers actually deploy this technology systematically, they keep finding things. Off the coast of Japan, near the island of Yonaguni, local divers discovered what might be the most controversial underwater structure in the world, the Yonaguni Monument, a massive rock formation that looks for all the world like a stepped pyramid, complete with apparently carved terraces, straight walls meeting at right angles, and what some researchers interpret as road-like features and carved symbols. The structure sits at depths between 16 and 80 feet. If it were on land, nobody would question that it was human-made. But because it's underwater, and because accepting it as artificial would require rewriting the entire timeline of Japanese prehistory, it's been the subject of fierce debate since its discovery in 1986. Marine geologist Masaki Kimura, professor emeritus from the University of the Ryukyus, has spent decades studying the site. He argues that while the base structure is natural sandstone, it was modified and shaped by human hands. He points to features that appear to be tool marks, the presence of apparent quarrying, and the geometric precision of certain angles and edges that rarely occur in natural formations. Skeptics, including geologist Robert Schoch, who examined the site, argue it's entirely natural, formed by tectonic activity and erosion along existing fracture planes in the sandstone. They say humans see patterns everywhere, even in random natural formations, and that the Yonaguni Monument is simply a case of pareidolia, seeing design where none exists. But here's what both sides agree on. The structure, whether natural or artificial, was above water during the last ice age. Sea levels in that region were 130 feet lower 12,000 years ago, which means the Yonaguni Monument was on dry land exactly when the great meltwater pulses were drowning coastlines worldwide. If humans did modify it, they would have done so before the floods. If it's natural but shows signs of human presence, that presence dates to before the site was submerged. Either way, it points to human activity in coastal areas that are now underwater, during the exact time period when those areas were being inundated. The same pattern repeats around the world. Off the coast of Cuba, sonar imaging in 2001 revealed what appeared to be regular geometric patterns at depth of 2,000 feet. The images showed what looked like symmetrical stone structures covering an area roughly the size of a city block. Follow-up investigations found more unusual features, but the extreme depth made detailed study nearly impossible with available technology. Natural formation or submerged ruins? Nobody knows for certain. Near Bimini in the Bahamas, divers have documented what appears to be a stone road or wall, massive limestone blocks arranged in a remarkably straight line for nearly 2,000 feet. The Bimini Road, as it's called, has been examined by geologists who argue it's just beach rock, a natural formation where beach sediments cement together. But the regular spacing and apparent quarry marks on some stones keep the controversy alive. Here's the thing about these controversial sites. They're controversial precisely because we have so little data. We can't definitively prove they're artificial, but we also can't definitively prove they're natural. And the reason we can't settle these debates is that we lack the resources to do proper, extensive underwater surveys of the areas in question. What we need is systematic, comprehensive mapping of the entire continental shelf, followed by detailed investigation of any anomalies. But that would cost billions and take decades. So instead, we get occasional surveys, brief investigations, and endless arguments about ambiguous sonar images and isolated dive reports. Meanwhile, The evidence that doesn't generate controversy keeps accumulating, evidence that's harder to dispute because it's less dramatic but more definitively human. Underwater caves throughout the world contain clear evidence of human occupation during periods when they were above water. The Yucatan Peninsula in Mexico is riddled with flooded cave systems that were dry during the Ice Age. Divers exploring these caves have found human remains, including the 13,000-year-old skeleton of a teenage girl dubbed Naya, along with stone tools, fire pits, and other artifacts. These caves weren't submerged by sea level rise. They flooded when the water table rose as ice melted. But they demonstrate that people were living in areas that are now underwater, in places we'd never think to look if we only surveyed dry land. The North Sea between Britain and continental Europe was entirely dry during the Ice Age, a vast plain called Doggerland that connected England to Holland, Germany and Denmark. This wasn't marginal territory. It was prime real estate with rivers, lakes and abundant wildlife. Tens of thousands of people must have lived there. When sea levels rose, all of it drowned. Today, fishing trawlers occasionally dredge up Stone Age tools, fragments of bone, and even carved artifacts from the North Sea floor. Each find is a reminder that an entire landscape of human occupation lies buried under modern shipping lanes. Off the coast of Denmark, underwater archaeologists have discovered submerged forests, ancient oak and pine trees still rooted where they grew 10,000 years ago, now standing in 30 feet of seawater. Among the preserved tree stumps, divers have found stone tools and animal bones showing butchering marks, evidence that humans were hunting and processing game in these forests when they were part of the dry coastal plain. The Baltic Sea contains dozens of submerged settlements, Stone Age fishing camps, and hunting sites that were on lake shores or coastlines when sea levels were lower. Sonar mapping has revealed preserved landscape features, ancient river channels, lake beds, even what appear to be stone fish traps, all now underwater. Each discovery reinforces the same basic truth. Vast areas of the continental shelf were occupied by humans during the Ice Age. When those areas flooded, the evidence of that occupation was preserved underwater. We're only beginning to find it because we're only beginning to seriously look. The technological revolution in underwater survey is revealing just how much we've missed. Modern sonar can now map the seafloor with resolution comparable to aerial photography of land. Autonomous underwater vehicles can survey areas too vast for human divers to cover. Machine learning algorithms can analyze sonar data to identify potential archaeological features automatically. As these technologies become more accessible, the pace of discovery is accelerating. In just the past decade, underwater archaeologists have identified thousands of previously unknown shipwrecks and hundreds of submerged prehistoric sites. Each survey reveals features that prompt more questions and demand more investigation. But here's the frustrating reality. For every site we investigate, there are probably hundreds we haven't found yet. The continental shelf is enormous. The areas most likely to have contained major settlements, river deltas, protected harbours, resource-rich coastal zones. Those are precisely the areas most heavily buried under sediment deposited by rivers over the past 11,000 years. Finding structures under 300 feet of water is hard. Finding structures under 300 feet of water and 50 feet of sediment is nearly impossible without extremely expensive, deep-penetrating sonar and extensive coring operations. This is why the debate about lost civilizations remains unresolved. It's not that the evidence doesn't exist. It's that the evidence is underwater, buried under sediment, scattered across millions of square miles of seafloor that we haven't surveyed yet. we're arguing about the existence of something we haven't actually looked for in most of the places it would be. Imagine if all evidence of modern civilization existed only in Central Australia, the Amazon rainforest, and Central Antarctica, and we'd only surveyed coastal California, trying to decide if complex human societies ever existed. That's essentially the situation with Ice Age coastal settlements. The evidence is there, we're just looking in the wrong places because the right places are underwater. So when someone claims there's no evidence of advanced societies before 6,000 years ago, what they really mean is, we haven't found evidence on dry land, which is exactly what you'd expect if those societies were living on coastlines that are now 300 feet underwater. The drowned world isn't theoretical, it's real. It's down there, waiting to be discovered. Every systematic survey of the continental shelf reveals new features. Every underwater excavation adds to our understanding of just how much we've lost to the rising seas. The question isn't whether coastal civilizations existed 12,000 years ago. The question is, when are we going to commit the resources necessary to actually find them? Because until we do, we're writing the history of humanity based on the fragments that happen to survive on high ground, while ignoring the vast library of evidence that lies beneath the waves. And that evidence isn't going anywhere. It's been waiting for 11,600 years. It can wait a little longer. But the longer we wait to look, the more we're letting our own assumptions about the past prevent us from discovering what actually happened. The ruins are down there, the settlements, the harbours, the monuments, all the evidence of the coastal peoples who watched their world slowly drown. We just have to be willing to get wet to find them. Now here's where things get really fascinating. Because 11,600 years ago, when those coastlines vanished beneath hundreds of feet of rising water, people survived. Not everyone, obviously. Thousands, maybe millions died as the waters rose, but some made it. They climbed to higher ground, they built boats, they moved inland ahead of the floods, and those survivors did what humans have always done when something catastrophic happens. They told stories about it. Fast forward to the 19th century, European scholars are translating ancient texts from around the world, and they start noticing something weird. Every culture, every civilization, everywhere on the planet has flood stories. Not just similar stories. Stories with the same basic plot, the same key elements, the same narrative structure. At first, they assumed this was proof that the Bible was literally true. The story of Noah's Ark was the original, and all other flood myths were corrupted versions passed down by the descendants of Noah's sons. Classic Victorian thinking. But then they dug deeper, and things got complicated. The Epic of Gilgamesh, discovered in the ruins of ancient Mesopotamia, was older than the biblical flood account. Much older. The tablets containing the flood story date to around 2100 BCE, centuries before the earliest biblical texts. In the Gilgamesh version, the hero Utnapishtim receives a warning from the god Ea that a great flood is coming. He's told to build a massive boat, seal it with pitch, and bring aboard his family and representatives of every living creature. Sound familiar? The flood comes, lasting 7 days and 7 nights. Water covers everything, even the mountains. When it finally recedes, Utnapishtim's boat comes to rest on a mountain. He sends out a dove, then a swallow, then a raven to find dry land. Only the raven doesn't return, signalling that the waters have receded enough for life to resume. The parallels to Noah's story are so exact that scholars realize they had to be connected somehow. Either one borrowed from the other, or both drew from an even older tradition. But then they found similar stories in cultures that had never had contact with the Middle East. In Hindu tradition, there's the story of Matsya. The god Vishnu takes the form of a giant fish and warns a king named Manu that a great deluge is coming. Manu builds a huge boat, loads it with seeds and animals, and ties it to Matsya's horn. The fish tows the boat through the cosmic ocean for years until the waters recede and life can begin again. This story appears in texts dating to at least 1500 BCE and probably originated much earlier in oral tradition. The ancient Greeks had Deucalion and Pyrrha. Zeus decides to destroy humanity with a great flood because humans have become wicked and corrupt. Prometheus warns his son Deucalion, who builds an ark and takes his wife Pyrrha aboard. They float for 9 days and 9 nights until their ark lands on Mount Parnassus. After the waters recede, they repopulate the earth. Different names, different gods, same basic story. Divine warning, boat construction, salvation through floating, mountain refuge, repopulation of the earth. But here's where it gets really interesting. These aren't just old world stories. Indigenous cultures in the Americas had flood myths too. The Hopi tell of 3 previous worlds that were destroyed, the third by water. Survivors escaped by climbing inside hollow reeds that floated on the surface until the waters receded. The Aztecs recorded that the 4th sun, the previous age of the world, ended when Chalhutlake, the goddess of water, flooded the earth. Humans survived by transforming into fish, and later a few were transformed back to repopulate the land. In South America, the indigenous peoples of the Andes tell stories of a great flood that destroyed the world. In one version from the pre-Inca cultures, a llama warns its shepherd that the ocean is about to rise and cover the earth. The shepherd and his family flee to a high mountain peak with their animals. The waters rise until they nearly reach the summit, and the llama worries that even this height won't be enough. Finally, the waters recede, and the family descends to find themselves the only humans left alive. North American tribes across the continent have flood traditions. The Ojibwe tell of Nanabojo, who climbs to the top of the tallest tree on the highest mountain as waters cover the earth. He sends out animals, a raven, then a muskrat, to find land beneath the waters. The Snohomish of the Pacific Northwest tell of a time when the ocean rose so high that even the mountains were covered. Survivors tied their canoes to the peaks of the tallest mountains and waited for the waters to fall. These stories were collected in the 18th and 19th centuries, before these cultures had significant contact with European Christian missionaries. They can't be explained as borrowed biblical narratives. They're indigenous, ancient traditions passed down through hundreds of generations. In Australia, Aboriginal peoples have stories about the sea rising and drowning the coastal lands. The Gunditj Mara people of southeastern Australia tell of a time when the sea level was much lower, and their ancestors could walk to what are now islands. Then the sea rose rapidly, flooding vast territories. Their stories describe specific geographical features that are now underwater. Port Phillip Bay, which is now a large bay near Melbourne, was once dry land according to these traditions. And you know what? Geological evidence confirms this. The bay was indeed a flat plain until about 10,000 years ago when rising seas flooded it. The Aboriginal peoples of the Gulf of Carpentaria in northern Australia have traditions describing when the Gulf was dry land, a vast plain where people hunted. Then the seas rose and transformed it into a shallow sea. Again, geological evidence confirms that the Gulf was indeed exposed land during the last ice age and was flooded around 11,000 to 12,000 years ago. Pacific Island cultures have similar stories. The Polynesians, despite living on volcanic islands that were never exposed continental shelf, have traditions of great floods that destroyed previous lands. Some scholars think these might be memories carried from their ancestors' original homeland in Southeast Asia, where massive coastal flooding absolutely occurred. In Africa, flood myths appear in cultures across the continent. The Kikuyu of Kenya tell of a great flood that covered the earth, except for the highest mountains. The Mandingo of West Africa have traditions of a catastrophic flood that destroyed the world. The Yoruba tell of a time when the primordial waters covered everything until the god Obatala created land. Now, here's what's wild about all of this. When you map out the geographical distribution of detailed flood myths, the most specific, most elaborate flood stories, you find them concentrated in exactly the regions that would have experienced the most dramatic coastal flooding at the end of the last ice age. Southeast Asia, with its vast exposed continental shelves, the Persian Gulf region, where hundreds of thousands of square miles of prime territory were drowned, the Mediterranean coasts, the Pacific coasts of the Americas, northern Australia. These are precisely the areas where Meltwater Pulse 1b would have caused the most catastrophic inundation, and the timing works too. Most scholars studying oral traditions estimate that detailed narratives can be reliably transmitted for about 10,000 years, maybe 12,000 years maximum, before they become too distorted to preserve specific information. That's exactly the time frame we're talking about. 11,600 years from the main flooding event to today. But there's a legitimate academic debate here. Some scholars argue that flood myths are universal because flooding is universal. Every culture experiences floods. Rivers overflow, storms cause storm surges, tsunamis hit coastlines, so every culture develops stories to explain these recurring disasters, and they naturally converge on similar narrative patterns, because human psychology is similar everywhere. Psychologist Carl Jung would have called them archetypal stories, emerging from the collective unconscious rather than from actual historical memory. This skeptical view held sway for most of the 20th century. Flood myths were considered interesting cultural artifacts but not historical evidence. Then marine archaeology changed everything. When researchers began systematically exploring the continental shelves using sonar and submersibles, they started finding things. Submerged river channels exactly where Aboriginal tradition said rivers used to flow. Drowned landscapes matching the descriptions in Pacific Islander oral histories. Ancient stone structures underwater off the coast of India, in locations where tradition spoke of flooded cities. In the late 1990s, oceanographers discovered something extraordinary in the Black Sea. The sea floor showed evidence of a catastrophic flood around 7,600 years ago, when rising Mediterranean waters breached a natural dam and flooded what had been a massive freshwater lake. The lake level rose by hundreds of feet in a matter of months, drowning thousands of square miles of inhabited territory. And guess what? The cultures that lived around the Black Sea, the ancestors of the people who would write down the Epic of Gilgamesh, would have experienced this disaster firsthand. This might be the specific event that generated the Mesopotamian flood narrative. But that Black Sea flood happened 4,000 years after Meltwater Pulse 1b. It could have reinforced older memories, adding new details to stories that were already circulating. Or there could have been multiple catastrophic flooding events, each adding to the cultural memory of the Great Flood. The most compelling evidence for historical accuracy in flood myths comes from the specific details. This isn't just about generic flooding. Many traditions describe particular aspects of sea level rise that wouldn't be obvious to people making up stories. The Ong people of the Andaman Islands in the Indian Ocean have a tradition that says their ancestors lived on a much larger island. but the sea came and broke it into many smaller islands. Bathymetric surveys show that the Andaman Islands were indeed part of a much larger landmass during the last ice age, and rising seas did fragment it into the current archipelago. Australian Aboriginal traditions speak of a time when you could walk to what is now Kangaroo Island off the coast of South Australia. They describe the drowning of the land bridge in detail. When? Archaeological evidence suggests the land bridge was finally severed by rising seas around 11,000 years ago. That's 440 generations of oral tradition preserving accurate geographical information. The Tsimshian people of British Columbia have a story about a mountain that used to be an island. Geological studies show that what is now a coastal mountain was indeed an island until about 12,000 years ago, when falling sea levels during a brief cold period connected it to the mainland. Then rising seas turned it back into a peninsula. The oral tradition captured both transitions. These aren't vague myths. These are precise geographical memories passed down across hundreds of generations. The anthropologist Patrick Nunn has spent decades researching Aboriginal Australian coastal myths and their correlation with actual geological changes. He's documented dozens of cases where oral traditions describe specific coastal features that were drowned by rising seas between 13,000 and 7,000 years ago, and the geological evidence confirms the accuracy of the stories down to remarkable detail. So how is this possible? How can oral traditions preserve accurate information for 400 to 500 generations? The answer lies in the structure of traditional knowledge transmission. These weren't casual campfire stories subject to random variation. They were sacred traditions, often tied to initiation ceremonies, land rights, and cultural identity. Indigenous cultures developed sophisticated mnemonic techniques to ensure accurate transmission. Stories were connected to songs, dances, and ritual performances. They were tied to specific landmarks and seasonal observances. Multiple people in the community knew the stories, creating redundancy. And there were often consequences, social or spiritual, for getting the stories wrong. Australian Aboriginal traditions show evidence of this structured transmission. Stories about sea level rise are often embedded in songlines, the traditional paths across the landscape that serve as both navigation aids and encyclopedic repositories of cultural knowledge. A songline might describe a journey that crosses what is now underwater, preserving the memory of the ancient landscape in a form that's nearly impossible to forget or distort. But there's another factor too. These stories mattered. They weren't entertainment. They were survival information. If your ancestors nearly died in a catastrophic flood, you make damn sure your children and grandchildren know about it. You tell them where the waters came from, how high they rose, where people survived. This is practical knowledge that might save lives if it happens again. That kind of information gets transmitted with far more accuracy than casual folklore. The common elements in flood myths worldwide, divine warning, boat construction, animal preservation, mountain refuges, these might not be mythological inventions. They might be descriptions of actual survival strategies. If you're living on a coastal plain and you see the waters rising day after day, year after year, you would look for high ground. Mountains become refuges. If the flooding is happening slowly enough, you'd gather resources. You'd try to preserve seeds, you'd try to save livestock, you'd build boats or rafts to escape. And if you believed in gods, which every culture in that period did, you'd interpret the disaster in religious terms. The gods are angry. The gods sent the flood. The gods warned the worthy ones who survived. The real debate isn't whether these stories are all independent inventions versus all deriving from a single source. It's more nuanced. Probably both things are true. There was a real historical event, the catastrophic sea level rise at the end of the Ice Age, that affected coastal peoples globally. Each affected population developed its own traditions describing their experience. These traditions were refined over thousands of years, acquiring mythological and religious elements. Then, as human populations expanded and cultures made contact, some of these stories influenced each other. The Mesopotamian version influenced the Hebrew version. The Greek version might have been influenced by contact with Middle Eastern cultures. But beneath all the cultural elaboration and cross-pollination, there's a core of historical truth. The water did rise, the coasts were drowned, civilizations were destroyed, and people remembered. They remembered for 11,600 years. They encoded the memory in stories that seemed like myths, but contained real information about real catastrophes. We're only now, with modern marine archaeology and geology, able to confirm what they've been telling us all along. The world drowned, and we survived. That's not mythology, that's history. So here's the uncomfortable question that keeps archaeologists up at night. When those floods erased 11 million square kilometers of habitable land, who exactly were they erasing? Because here's the thing about coastal populations, they're invisible. We find ancient settlements inland because they stayed where we can reach them. They're sitting in deserts and valleys and mountain caves, waiting for someone to dig them up. But the coast is 120 meters underwater. Everything that existed there, every settlement, every trading post, every seasonal camp, every innovation, it's all gone, buried under sediment and salt water for 11,600 years. And that should terrify you, not because it's creepy, but because of what it means for our understanding of human history. We've built our entire narrative of civilization on the stuff we can find, on the settlements that happen to be inland. But what if the best places to live, the most productive territories, the centres of population and innovation were all on the coast? What if everything we think we know about the development of human civilization is based on the leftovers? The inland sites that survived because they were in the wrong place? Let's start with what we actually know. By 13,000 years ago, humans had been behaviourally modern for tens of thousands of years. They weren't cavemen grunting and hitting each other with clubs. They were us. Same brain capacity, same cognitive abilities, same capacity for abstract reasoning, art, technology, and social organisation. They'd already spread across every continent except Antarctica. They'd survived the last glacial maximum, the coldest period of the entire Ice Age. They developed sophisticated hunting techniques, complex social networks, and extensive trade routes that moved obsidian, shells, and other valuable materials across hundreds of miles. These weren't simple people living simple lives. They were complex hunter-gatherers with detailed knowledge of their environments, seasonal migration patterns, medicinal plants, animal behavior, and celestial navigation. Many groups were already living in semi-permanent settlements, returning to the same locations year after year, building structures that would last multiple generations. And where were the best places for these settlements? The coast, obviously. Coastal environments are resource bonanzas. You've got fish, shellfish, seaweed, seabirds, seabird eggs, seals, sea turtles, and marine mammals. You've got easy transportation via boats. You've got trade routes that follow the coastline connecting distant populations. You've got estuaries where freshwater rivers meet the sea, creating incredibly productive ecosystems that support massive concentrations of game animals and edible plants. Basic ecological logic tells us that coastal populations would have been larger, more sedentary, and more complex than inland groups. They had access to more reliable food sources. They could support higher population densities. They had more opportunities for specialization and trade. They could accumulate knowledge and pass it down through generations without the constant disruption of migration. But we can't see them anymore. They're underwater. Except for the weird stuff that survived inland. Sites that are so anomalous, so sophisticated, so out of place in our conventional timeline that they force us to reconsider everything. Take Göbekli Tepe. 11,500 years ago, right after the main flooding event, someone in southeastern Turkey decided to build something unprecedented in human history. Massive stone pillars, some weighing up to 20 tons, carved with intricate reliefs of animals, geometric patterns, and abstract symbols, arranged in circular enclosures that required thousands of hours of coordinated labour. Built by people who, according to conventional archaeological timelines, were supposed to be simple hunter-gatherers without sophisticated social organisation or architectural knowledge. But here's what makes Göbekli Tepe truly mind-blowing. It wasn't built by farmers. There's no evidence of agriculture at the site, no domesticated plants or animals, no permanent dwellings. The people who built it were hunter-gatherers, mobile groups who somehow organised themselves into work parties capable of quarrying, transporting, carving and erecting stones that would challenge modern construction equipment. This isn't supposed to be possible. Everything we thought we knew about human social development said you needed agriculture first. You needed surplus food production to support specialists who didn't spend all their time gathering food. You needed sedentary populations that stayed in one place long enough to justify massive construction projects. Göbekli Tepe says we were wrong, dead wrong. It proves that complex social organization, monumental architecture, and sophisticated symbolic culture could exist before agriculture, before cities, before everything we thought was necessary for civilization. But here's the really interesting part. Göbekli Tepe isn't unique anymore. In the last 2 decades, we've found dozens of similar sites across the Middle East and Anatolia. Karahan Tepe, Nevali Chori, Harbetsuvan Tepesi, Sayburç, all of them built roughly 11,000 to 10,000 years ago, all of them featuring massive stone constructions, sophisticated carvings, and evidence of organized labor that shouldn't be possible for hunter-gatherer societies. And they're all inland, miles from any coast, ancient or modern. Which raises an obvious question. If inland hunter-gatherers could build Göbekli Tepe, what were coastal populations building? Put yourself in the position of a survivor. The floods have destroyed your home, your ancestral territories, everything your people have known for generations. You've fled inland with whatever you could carry. You're traumatized, displaced, living in territories that are already occupied by other groups. But you remember the old ways, the coastal settlements, the boats, the navigation techniques, the social organizations that allowed your people to thrive when times were good. And you need to recreate something, some physical manifestation of what was lost, some way to preserve the knowledge and social cohesion that kept your people organized before the disaster. So you build. Not homes, those come later. Not fortifications, those can wait. You build ritual centers, meeting places, architectural representations of cosmic order, places where scattered survivors can gather, share knowledge, maintain social bonds, and pass on critical information to the next generation. That's what Göbekli Tepe and its sibling sites might actually be. Emergency cultural preservation projects, built by coastal refugees who are trying to prevent the complete loss of their social and technological heritage. The timing supports this interpretation perfectly. Most of these megalithic sites date to 11,500 to 10,000 years ago, right after the main flooding events, right when you'd expect displaced populations to be reorganizing inland, creating new social structures, trying to preserve whatever they could from the drowned world. And the animal carvings at these sites, their maritime species, seabirds, fish, marine predators, creatures that would have been central to coastal economies, but that inland populations would rarely encounter. The builders were remembering their old lives, carving stone memories of the world they'd lost. But the conventional archaeological response to this idea is predictable. Show us the evidence, show us the coastal settlements, the ports, the trading centres, the sophisticated societies you claim existed before the floods. Show us physical proof that coastal populations were more advanced than inland groups, and we can't, because it's all underwater, except when it isn't. In the last 30 years, maritime archaeology has begun finding exactly what you'd expect if sophisticated coastal populations existed before the floods. Submerged stone structures off the coast of India, Japan, and the Mediterranean. Ancient shorelines with tool scatters and fire pits now 60 meters underwater. Preserved shipwrecks and navigational technology that proves pre-agricultural societies had sophisticated maritime capabilities. Off the coast of Gujarat in India, researchers have found submerged structures in the Gulf of Kambat that some argue show evidence of urban planning, gridded layouts, building foundations, artifacts that suggest organized construction. The conventional archaeological community remains skeptical, pointing out that underwater sites are hard to interpret, that natural formations can look artificial, that dating is problematic. But skepticism doesn't mean the evidence doesn't exist. It just means we're uncomfortable with its implications. Then there's the genetic evidence. And this is where things get really interesting. Because population genetics doesn't care about archaeological politics. It just records what happened. When you look at genetic diversity in modern human populations, you see something strange. Multiple population bottlenecks occurring right around the time of the flooding events. Sudden reductions in genetic diversity, followed by rapid population expansions and migrations inland from coastal regions. This is exactly what you'd expect if large coastal populations were displaced by flooding, experienced massive die-offs, and then sent survivors fleeing into interior territories. The genetic signature of catastrophic coastal flooding is written in our DNA. We just weren't looking for it until recently. Even more revealing are migration patterns. Genetic analysis shows major human population movements occurring 12,000 to 10,000 years ago. Groups from coastal regions expanding rapidly into interior territories, mixing with established inland populations, creating new genetic lineages that combine coastal and inland ancestry. These aren't gradual migrations spread over thousands of years. They're rapid displacements, the genetic signature of refugees, and those refugees brought knowledge with them, maritime technology, navigation techniques, social organizational systems, astronomical knowledge, architectural concepts, everything they developed over thousands of years of coastal living. This might explain one of the biggest mysteries in human prehistory. How did agriculture develop so quickly in so many different places at almost the same time? For decades, archaeologists have been puzzled by the Neolithic Revolution. Around 10,000 years, ago, multiple societies across the world independently began domesticating plants and animals within a few thousand years of each other. The Middle East develops wheat and barley. China domesticates rice. Mesoamerica develops maize. The Andes domesticate potatoes. New Guinea develops taro and banana cultivation. It's like the entire world suddenly decided agriculture was a good idea after millions of years of hunting and gathering. The conventional explanation is that it was a response to climate change. As the world warmed after the Ice Age, megafauna went extinct and large game hunting became less viable. Humans had to intensify their food production, leading independently to agriculture in multiple regions. It's a reasonable theory, except it doesn't explain the timing. Why did all these separate regions develop agriculture within a few thousand years of each other? Why not gradually over tens of thousands of years? But what if agriculture wasn't invented? What if it was remembered? What if coastal populations had already been practicing proto-agriculture before the floods? Managing wild plant populations, selecting for desirable traits, creating semi-domesticated varieties that required minimal intervention. Then the floods hit, destroying coastal settlements and forcing survivors inland into less productive territories. Suddenly, you need intensive agriculture to support the same population, densities you'd maintained easily on the coast with fishing and gathering. So you scale up the techniques you already knew. You turn proto-agriculture into full agriculture. You intensify cultivation because you have to. This would explain the rapid simultaneous development of agriculture in multiple regions. It wasn't independent invention. It was displaced knowledge being applied in new environments by populations that had no other choice. The Neolithic revolution wasn't a revolution at all. It was an adaptation to catastrophic displacement, and it would explain the sophisticated social organization that appears suddenly in the archaeological record right after the flooding period. How did people who were supposedly simple hunter-gatherers suddenly know how to organize large-scale labor projects, establish trade networks spanning hundreds of miles, create complex ritual systems, and build permanent settlements with sophisticated architecture? Maybe because they weren't simple hunter-gatherers. They were refugees from complex coastal societies, trying to recreate what they'd lost. This brings us to the controversial part, the idea that genuinely advanced civilizations existed before the floods and were completely destroyed, leaving only scattered traces and cultural memories. The ancient astronaut crowd loves this theory. Atlantis, Lemuria, Mu, all the lost continent mythology that drives serious archaeologists crazy. And honestly, most of it is nonsense. There's no evidence of cities with advanced technology 12,000 years ago. No metal, tools, no written language, no wheels, no domesticated animals, none of the markers we associate with civilization. But that's defining civilization pretty narrowly. What if we expand the definition? What if we accept that sophisticated doesn't necessarily mean technological in the way we understand it? A society could be highly organized, culturally complex, and architecturally advanced without leaving behind metal tools or written records. Stone Age doesn't mean stone stupid. It just means the tools that survived were made of stone. The real question isn't whether lost advanced civilizations existed. It's what we mean by advanced. If by advanced we mean technologically equivalent to Bronze Age or later societies, then no, there's no evidence for that. But if by advanced we mean populations with sophisticated social organization, extensive trade networks, monumental architecture, detailed astronomical knowledge, complex ritual systems, and the ability to support specialist craftspeople, then yes, there's increasing evidence that such societies existed on the coasts before the floods. They weren't building starships or pyramids, but they might have been building impressive wooden structures, boats capable of long-distance navigation, and complex settlements that supported hundreds or thousands of people, all of which would be completely invisible in the archaeological record after 11,600 years underwater. Wood rots, rope disintegrates, organic materials vanish. Stone tools survive, but they don't tell you much about social complexity. What also survives is memory. Cultural memory passed down through generations, encoded in myths, legends, and origin stories. And when you look at flood myths from around the world, you see something fascinating. They're not just stories about water rising. They're stories about lost knowledge, destroyed civilizations, and survivors who had to rebuild from scratch. The Sumerian flood myth doesn't just describe the disaster, it describes the world before, a time when kings lived in cities, when knowledge was advanced, when civilization flourished. Then the flood comes, destroys everything, and survivors have to start over. The biblical flood story follows similar patterns. A world that had become complex and corrupt, destroyed by water, with only a faithful remnant surviving to repopulate the earth. The Hindu Matsya Purana describes Manu, the first man who survives a great flood and preserves the Vedas, the sacred knowledge that must not be lost. Native American flood myths describe survivors fleeing to mountaintops while the waters consume the lowlands. Polynesian legends tell of islands that sank beneath the waves, forcing ancestors to voyage to new lands. Australian Aboriginal stories describe times when the coastline was far out beyond where it is now, when lands that are now underwater were dry and inhabited. These aren't identical stories. They come from different cultures, different continents, different linguistic groups, but they share common elements that are suspicious if you're trying to explain them as pure mythology. They're not just creation myths, they're destruction and recreation myths. They describe a world that was lost and that had to be rebuilt by survivors who remembered the old ways. That's the signature of cultural trauma, of populations that experienced catastrophic displacement and encoded the memory and oral traditions that lasted thousands of years. It's not proof of advanced lost civilizations, but it's consistent with the idea that complex coastal societies existed before the floods and that their destruction was remembered by survivors for thousands of years afterward. The academic controversy around this topic is intense. Mainstream archaeology is justifiably skeptical of claims that can't be verified with physical evidence. The field has been burned too many times by sensational claims of lost civilizations that turned out to be natural formations, misinterpreted sites, or outright hoaxes. Professional caution is warranted when the evidence is underwater and interpretation is difficult, but skepticism shouldn't become dogma. The fact is, we know almost nothing about coastal populations before the floods because we can't access their settlements. We're basing our entire understanding of human social development on inland sites that may not be representative of where most people actually lived. That's like trying to understand modern civilization by excavating only mountain villages while ignoring that most people live in coastal cities. The truth is probably somewhere between the extremes. No, there weren't ancient astronauts or Atlantean super-civilizations with crystal power technology. But yes, there were probably complex, sophisticated hunter-gatherer societies on the coasts that were more socially organized, more architecturally advanced, and more populous than the inland sites we've been studying. They weren't civilizations in the classical sense. No writing, No large-scale agriculture, no cities. But they were complex enough that their destruction constituted a genuine catastrophe for human social development. Complex enough that survivors remembered them for thousands of years. Complex enough that when they were displaced inland, they brought knowledge that jump-started the Neolithic Revolution and the development of true civilization. The coastal peoples who drowned 11,600 years ago weren't primitive savages. They were us, smart, adaptable, innovative people who had spent thousands of years developing sophisticated adaptations to their environments. They built boats, navigated by stars, traded across vast distances, organized large work parties, created art, developed ritual systems, and passed knowledge across generations. When the floods came, most of them died. But the survivors became our ancestors. They fled inland, integrated with existing populations, and within a few thousand years, their descendants had developed agriculture, built cities, and created the first historically recognized civilizations. We call those civilizations the cradles of human culture. Mesopotamia, Egypt, the Indus Valley, China. But maybe they weren't cradles. Maybe they were refugee camps that became successful, founded by people who remembered a drowned world and were determined not to let everything their ancestors had built be forgotten forever. That's who the coastal peoples were. They were us before the world drowned. And even though their settlements are gone, their legacy survived. It's in every agricultural field, every boat, every navigation technique, every architectural tradition, every flood myth that warns future generations about the danger of rising waters. They're in our DNA, in our culture, in the very foundations of everything we call civilization. We are what they became after they lost everything. We are their second chance. And 11,600 years later, we're facing the same rising seas they did, wondering if we'll be any better at adaptation than they were at survival. Now here's where this ancient story becomes uncomfortably relevant to our modern world. Because what happened 11,600 years ago isn't just history, it's a preview, a warning written in drowned coastlines and submerged settlements that we're only now learning to read. Let's talk numbers. Real, current, terrifying numbers. Today, right now, approximately 2.4 billion people live within 100 kilometers of a coastline. That's nearly 1/3 of all humans on Earth. About 600 million live in coastal zones that sit less than 10 meters above sea level. In practical terms, that's the elevation of a 3-story building. One really good storm surge, one unusually high tide combined with the wrong weather conditions, and these areas flood. But we're not talking about storms anymore. We're talking about permanent sea level rise. And the projections aren't reassuring. Current climate models, the conservative ones that assume we somehow manage to reduce carbon emissions significantly, predict sea level rise of at least 1 to 2 meters by the year 2100. That's just 76 years from now. Well, within the lifetime of anyone under 50 reading this, the less conservative models, the ones that assume we continue on our current trajectory, predict 2 to 3 meters, maybe more. Now 2 meters doesn't sound like much. It's about 6.5 feet. You could stand in water that deep and keep your head above the surface. But here's what 2 meters of sea level rise actually means. It means goodbye to Miami. Not parts of Miami. All of Miami. The entire city sits at an average elevation of less than 2 meters above current sea level. The downtown area, where millions of people live and work, where billions of dollars of real estate and infrastructure exist, would be permanently underwater. It means goodbye to Venice. The city that has survived for 1,500 years by building on wooden pilings in a lagoon would finally succumb to the rising Adriatic. It means goodbye to Bangladesh's southern coast, where 30 million people currently live on land that would be submerged. It means goodbye to the Maldives, Tuvalu, Kiribati, entire nations that would simply cease to exist above sea level. It means massive portions of New York City, London, Shanghai, Mumbai, Bangkok, Jakarta, and hundreds of other major coastal cities would require permanent flooding defences or eventual abandonment. And we're not talking about some distant future. We're talking about decisions that need to be made in the next 10 to 20 years. Infrastructure that needs to be planned and built now. Populations that need to be relocated soon. The total economic value of infrastructure in zones vulnerable to 2 meters of sea level rise exceeds $20 trillion. That's not a typo. $20 trillion of buildings, roads, ports, utilities, all of it built on land that will be underwater within most of our lifetimes. But here's what makes this worse than what happened 11,600 years ago. When Meltwater Pulse 1b hit, when the seas rose 13 to 15 meters in maybe 500 years, the people living on those drowned coastlines had options. Terrible, brutal options that involved abandoning everything they'd built and walking away, but options nonetheless. They could migrate, they could move inland, they could find new territories, new hunting grounds, new places to build settlements. The world was mostly empty. Maybe 5 million humans total on the entire planet. When coastal populations fled inland, they found space, they found resources, they could rebuild. We don't have that option. Every piece of habitable land on Earth is claimed by someone. Every border is defended, every resource is allocated. When 600 million coastal residents need to move inland, where exactly are they supposed to go? Bangladesh can't just absorb 30 million climate refugees. The country's already one of the most densely populated on Earth. Indonesia can't relocate Jakarta's 30 million residents to higher ground without massive social and economic disruption. The United States can't abandon Miami and New York and just rebuild somewhere else. The infrastructure investment alone would bankrupt most nations. And that's assuming governments cooperate, assuming borders stay open, assuming wealthy inland regions welcome climate refugees from coastal areas. History suggests none of those assumptions are safe. When resources get scarce and populations get desperate, humans don't tend toward generosity. They tend toward walls, both literal and metaphorical. The ancient coastal peoples who fled Meltwater Pulse 1b faced horror, but they faced it in a world that still had room for refugees. We're facing similar changes in a world where there's nowhere left to run. But wait. You might be thinking, Meltwater Pulse 1b took 500 years, maybe longer. We're talking about similar sea level rise over 76 years. That's way faster. And you'd be absolutely right. The rate of change we're experiencing is unprecedented in the entire history of human civilization. Our ancestors had centuries to adapt. We have decades. Except here's the really uncomfortable part. The speed of Meltwater Pulse 1b is still debated. Some evidence suggests the bulk of that 13 to 15 meters of sea level rise happened in just 100 to 200 years. Maybe even faster. There are geological signatures in coral reefs and coastal sediments that point to extremely rapid pulses of sea level rise. Not gradual, linear increase over centuries, but sudden catastrophic jumps. Years when the ocean rose meters, not millimeters. Why does this matter? Because it means it's happened before. Rapid, catastrophic sea level rise. Not theoretical, not modelled, actually happened, within human memory, and it could happen again. One of the biggest uncertainties in current climate models is the stability of ice sheets in Greenland and Antarctica. These aren't glaciers, they're continental masses of ice kilometers thick containing enough frozen water to raise global sea levels by over 60 meters. Current models treat their melting as gradual, predictable, linear. But paleoclimate evidence from past warming periods shows these ice sheets can collapse suddenly, not over thousands of years, but over decades or even years. When massive ice shelves finally detach, when the glaciers they were holding back accelerate into the ocean, sea level doesn't rise gradually. It jumps. We saw a preview in 2002 when the Larsen B ice shelf in Antarctica, an area the size of Rhode Island, collapsed in just 35 days. It had been stable for at least 10,000 years. Then it was gone. The glaciers it had been restraining immediately accelerated, flowing into the ocean 5 times faster than before. That was a small ice shelf. If the West Antarctic ice sheet destabilizes, we're talking about 3 to 5 meters of sea level rise. If the Greenland ice sheet goes, that's another 7 meters. If both go, we're looking at sea level rise similar to what happened at the end of the Younger Dryas, except it would be happening to a world with 8 billion people, not 5 million. A world where most major cities are on coastlines. A world with no empty lands to retreat to. Now, most scientists think catastrophic ice sheet collapse is unlikely in this century. Emphasis on unlikely, not impossible. The probability isn't zero. And the consequences would be civilization ending for many coastal nations. This is the kind of low probability, high consequence risk that keeps climate scientists awake at night. But let's assume the pessimists are wrong. Let's assume sea level rise stays in that 1 to 2 meter range over the next century. That's still catastrophic. That still displaces hundreds of millions of people. That still destroys trillions in infrastructure. And unlike our ancestors, we can see it coming. We know it's happening. We have the data, the models, the archaeological evidence of past flooding events. We know what's at stake. So what are we doing about it? Some places are adapting. The Netherlands, which has been fighting the sea for centuries, is building increasingly sophisticated flood defense systems. They've already protected land that sits below sea level. They're experts at this. But even Dutch engineers admit there are limits. At some point, the cost of defending land becomes greater than the value of the land itself. At some point, you have to retreat. Venice is experimenting with mobile flood barriers that can be raised when high tides threaten. It's a marvel of engineering, except it was designed for the climate of the past, not the climate of the future. The barriers need to be raised more frequently every year. Eventually, they'll need to be raised permanently. At which point, Venice stops being a city and becomes an aquarium. Some cities are exploring managed retreat, buying out coastal properties, relocating infrastructure inland, creating buffer zones that can flood without destroying homes. It's expensive. It's politically unpopular. Nobody wants to be told their home will be underwater in 30 years, but it's happening. Slowly, reluctantly, not nearly fast enough. Other places are in denial, building new coastal developments on land that will flood, selling beachfront property that will be underwater, issuing 30-year mortgages on homes that won't survive 15 years. It's a collective delusion, driven by the human tendency to assume the future will resemble the past. It won't. But here's what really matters. Here's why understanding what happened 11,600 years ago is crucial for our survival. Those ancient floods taught our ancestors hard lessons about resilience and adaptation. Lessons written in genetic memory and cultural tradition. Lessons we're only now rediscovering. First lesson. The coast isn't permanent. Every flood myth, every story of a drowned world carries the same warning. Don't build your civilization on the assumption that sea level is stable. It isn't. It never has been. Every major culture that survived the floods did so because they maintained connections inland. They had trade networks, kinship ties, secondary settlements in highlands. When the coast flooded, they could retreat. Modern coastal cities, hyper-specialized and disconnected from their agricultural hinterlands, have lost this flexibility. Second lesson. Speed matters. Gradual sea level rise, even substantial rise over centuries, is manageable. Civilizations can adapt. They can relocate slowly. They can rebuild infrastructure incrementally. Rapid sea level rise, the kind that might accompany ice sheet collapse, is existential. There's no adapting to losing 20% of your habitable land in a generation. There's only chaos. Third lesson. Cooperation is survival. The civilizations that survived the younger Dryas floods did so by maintaining networks of mutual support. When one settlement flooded, others took in refugees. When resources became scarce, they shared. The alternative was collapse. Modern nationalism, with its emphasis on borders and sovereignty, is a luxury of stable climate. When the water rises, when hundreds of millions of people need to move, those borders will either open voluntarily or be overwhelmed by desperation. Fourth lesson. Knowledge preservation is critical. The societies that recovered fastest from the floods were those that maintained technical knowledge. Tool-making techniques, agricultural practices, construction methods. They didn't have to reinvent everything. They could rebuild because they remembered how. Modern civilization is far more complex but also far more fragile. If coastal cities flood and critical infrastructure is lost, can we rebuild it? Do we have the knowledge distributed widely enough? Or is it concentrated in the very coastal zones that will be underwater? And finally, the most important lesson. The one that the archaeological evidence screams at us from every drowned settlement and submerged structure. Warning signs matter. Those ancient peoples saw signs of change. Rising water tables, increased flooding, storms getting worse. Some responded by moving early, others waited, hoping the changes would reverse, hoping it wasn't as bad as it seemed. Most of those who waited too long didn't make it. Their settlements were swallowed by the sea, their names forgotten, their stories preserved only in flood myths and genetic signatures of population bottlenecks. We're seeing the same warning signs now, except ours come with data, with measurements, with projections. We don't have the excuse of ignorance that ancient peoples had. We know what's happening. We know why. We know approximately how much time we have. The question isn't whether we'll respond. We will. Eventually. The question is whether we'll respond while there's still time to manage the transition, or whether we'll wait until crisis forces desperate, chaotic reaction. Right now, the research continues. Marine archaeologists are surveying continental shelves using advanced sonar and submersibles to map submerged settlements from the end of the Ice Age. Every discovery adds detail to our understanding of what happened when the world drowned, how fast it happened, how people responded, what worked and what didn't. These aren't just archaeological curiosities, they're case studies in civilizational resilience under climate catastrophe. They're lessons in what happens when you ignore sea level rise until it's too late. They're warnings written in stone and shell and drowned architecture, preserved for 11,600 years for us to find. Some scientists are proposing systematic surveys of all continental shelves, a global effort to map and study submerged Ice Age settlements before they're lost to erosion and development. The political will for such projects is limited, the funding uncertain, but the knowledge those submerged sites contain could be crucial for understanding our own future. Because here's the thing about those drowned civilizations: they weren't stupid. They weren't ignorant or primitive. They were humans, just as intelligent as us, living in a world they understood. They built on coastlines because coastlines offered resources, trade routes, food sources. They invested in infrastructure because they expected it to last. They raised children and built communities with the expectation of continuity. They were wrong. The world changed. The seas rose, and everything they built was swallowed by water. We're making the same bet they did, assuming stability in a fundamentally unstable system, building permanent infrastructure on temporary coastlines, investing trillions in cities that won't survive the century, planning for futures that won't exist. The difference is we know better. We have the data. We have the warnings. We have the archaeological evidence of what happens when you ignore rising seas. We have every advantage our ancestors lacked except one: time. And we're running out of it faster than most people realize. The great coastal floods of 11,600 years ago erased civilizations we're only now rediscovering. The question facing us isn't whether modern coastal cities will face similar fates. They will. The question is whether we'll learn from the past or repeat it. Whether we'll adapt while there's still time, or wait until the water is rising past our doorsteps and it's too late to do anything but flee. So here we are, back where we started, 11,600 years ago, the ice melting, the oceans rising, an entire world drowning beneath waves that would never recede. But now you understand what was actually lost. Not just land, not just coastline, not just convenient places to build villages. We lost civilizations, complex societies with their own technologies, their own trade networks, their own accumulated knowledge spanning thousands of years. We lost everything they'd learned about navigation, agriculture, astronomy, medicine. We lost their art, their stories, their understanding of the world. All of it buried under 400 feet of seawater. All of it waiting in the darkness. The evidence is overwhelming. The geological record shows it clearly. Meltwater pulse. 1B. 16 feet of sea level rise in less than 500 years. Coastlines retreating miles inland within single lifetimes. River valleys flooding. Islands vanishing. Entire continental shelves transformed from habitable land into ocean floor. The underwater archaeology confirms it. Megalithic structures off the coast of Japan, stone circles in the Persian Gulf, submerged settlements from India to the Mediterranean, pottery, tools, building foundations, all found in water too deep for any pre-modern civilization to have built there. Unless, of course, they built them when those locations were dry land, which they were 12,000 years ago. And the cultural memory seals it. The flood myths aren't just stories. They're not primitive superstition or religious metaphor. They're eyewitness accounts passed down through hundreds of generations. The details are too consistent. The geography is too specific. The timeline matches too perfectly. When cultures from Mesopotamia to Australia to the Pacific Islands to the Americas all describe the same catastrophic flooding event, you don't dismiss it as coincidence. You recognize it as history. But here's what really keeps me up at night. What we've discovered so far is just the tiniest fraction of what's down there. Think about it. We've explored less than 5% of the ocean floor. Less than 5%. That means 95% of the submerged world from 11,600 years ago remains completely unstudied, unexamined, unknown. There could be entire cities down there, major population centres with thousands of inhabitants, architectural achievements that would rival anything we know from the ancient world, libraries if they had developed writing, art galleries, temples, markets, universities, all preserved in sediment, waiting for someone to find them. The Dogolan settlements we're discovering in the North Sea, the submerged villages off India's coast, the megalithic structures scattered across continental shelves worldwide. These aren't anomalies, they're samples, random data points that hint at a much larger pattern. For every site we've found, there are probably hundreds we haven't. For every artifact recovered, thousands remain buried. And it's not just physical structures, it's knowledge. The coastal peoples who drowned in the floods had been living in those environments for thousands of years. They understood maritime navigation, tidal patterns, ocean currents, marine resources. They had developed technologies specifically adapted to coastal living, boat-building techniques, fishing methods, ways of preserving seafood, systems for predicting storms and managing seasonal variations. All of that expertise vanished with them. Think about how differently human civilization might have developed if those coastal societies had survived, if their knowledge had been preserved and built upon instead of being erased. Maybe we would have developed advanced seafaring capabilities thousands of years earlier. Maybe global trade networks would have emerged in the Stone Age instead of the Bronze Age. Maybe the entire trajectory of human technological development would have been fundamentally different. Instead, the survivors, the people who had been living inland, slightly higher up, far, enough from the coast to escape the worst flooding, they had to start over. Not from zero, exactly. They carried memories of the drowned world, stories of what had been lost, but they couldn't access the accumulated knowledge of coastal civilizations, couldn't learn from their innovations, couldn't build on their achievements. So human civilization took a different path. The path we know. Agriculture developing in river valleys instead of coastal plains. Cities rising inland instead of along ancient shorelines. Maritime technology emerging slowly, painfully, rediscovering techniques that coastal peoples might have perfected millennia earlier. The great floods of 11,600 years ago didn't just drown land. They drowned possibilities, alternate timelines, different futures that humanity might have pursued if those coastal civilizations had survived to shape our species' development. And the ocean keeps those secrets, holds them in cold darkness, waiting. Which brings us to the question we started with. What else is down there? What other evidence of sophisticated pre-flood societies remains undiscovered on continental shelves worldwide? What technologies, what achievements, what understanding of the world was lost beneath the waves? We don't know, not yet. But every year, underwater archaeologists make new discoveries. Every expedition reveals something unexpected. Every sonar survey shows structures that shouldn't exist where they are unless the coastline was completely different. The drowned world is giving up its secrets. Slowly, one site at a time, one artifact at a time, one piece of evidence at a time that our understanding of human prehistory is incomplete, that there's an entire chapter of our species' story written in sediment and stone beneath the waves. So if this video made you think differently about ancient history, hit that like button. Drop a comment telling me where you're listening from and whether your region has its own flood myths or submerged archaeology. And subscribe, because we're going to keep exploring these ancient mysteries, keep diving into the evidence that challenges everything we thought we knew about early human civilizations. Because somewhere down there, in the darkness, on continental shelves that used to be coastal plains, the drowned world is waiting to be remembered. And when we finally bring its secrets back to the surface, we might discover that human civilization is far older, far more sophisticated, and far more interesting than we ever imagined.